I am going to present about double sideband suppressed carrier AM. Before that, let's have a small introduction about AM. In amplitude modulation, the message signal M of t is impressed on the amplitude of carrier signal C of t equal to AC cos 2 pi fct, where AC is amplitude of carrier and Fc is frequency of carrier. This results in a sinusoidal signal whose amplitude is a function of message signal M of t. There are several different ways of modulating the carrier signal by M of t, such as double sideband suppressed carrier, conventional double sideband AM, single sideband, vestigial sideband. Each results in different spectrum characteristics of a transmitting signal. A Dsb Sc AM signal is obtained by multiplying the message signal M of t with the carrier signal C of t equal to AC cos of 2 pi fct, and U of t is equal to M of t into C of t. On substituting the value of C of t, we get AC M of t cos 2 pi fct, where M of t is message signal, C of t is carrier signal, and U of t is modulated signal. This is an example of message signal M of t. The relatively slowly varying message signal M of t is changed into rapidly varying modulated signal U of t. Due to this, its rapid changes with time, it contains higher frequency components. At the same time, the modulated signal retains the main characteristics of message signal. Therefore, it can be used to retrieve the message signal at the receiver. Spectrum of Dsb Sc AM signal. The spectrum of the modulated signal can be obtained by taking Fourier transform of U of t. So thus we get U of f is equal to AC by 2 M of f minus fc plus M of f plus fc. The magnitude of the spectrum of the message signal M of t has been translated or shifted in the frequency by an amount fc. The bandwidth occupancy of the amplitude modulated signal is 2W, whereas the bandwidth of the message signal M of t is W. Therefore, the channel bandwidth required to transmit the modulated signal U of t is Bc equal to 2W, where Bc is carrier bandwidth. The frequency content of the modulated signal U of t in the frequency band. Modulo f greater than fc is called upper sideband of U of t, and the frequency content in the frequency band modulo f lesser than f of c is called lower sideband of U of f. Either one of the sidebands of U of f contains all the frequencies that are in MF. Since U of f contains both upper and lower sidebands, it is called a double sideband AM signal. The pic shown in the left top, this is magnitude spectra of M of f, and the right side shown here is the phase spectra of M of f. As this is a double sideband suppressed carrier, we have two spectra, one on the left and other on the right. Which has frequency minus fc and plus fc, and it has an amplitude of AC by 2 into A. The phase spectra of double sideband AC is shown below. The other characteristics of modulated signal u of t is that it does not contain any carrier component. All the transmitted power is contained in the modulated signal m of t. This is evident from observing the spectra of u of f. As long as m of t does not have any DC component, there is no impulse in u of f at f is equal to fc. This would be case if the carrier component was contained in the modulated signal. For this reason, u of t is called a suppressed carrier signal. Therefore, u of t is a double sideband suppressed carrier amplitude modulated signal.